And read the announcement. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually we're going to go on to section 8.3, but first we have a question from section 8.2, and this is part 2, and it's number 9, and let's take a look at it on the screen. All right, write an equation for a linear function whose graph has the given characteristics. Okay, it passes through the point 15, 0, and it is perpendicular to the graph of g of x equals 3x plus 8. Okay, so let's go back to the whiteboard screen again. This symbol right here means perpendicular. All right, so when two lines are perpendicular to each other, their slopes are negative reciprocals of each other. G of x equals 3x plus 8 is in slope-intercept form. So the slope of g of x is 3. The negative reciprocal of that would be negative 1/3. So the slope of the line that's perpendicular, and I'm going to just use slope, little perpendicular symbol, would be negative 1/3. So that's the slope I'm going to use moving forward. Okay. So y equals mx plus b. Y equals negative 1/3 x plus b. We're going to take the ordered pair that we're given on the new line. X is 15, y is 0. So 0 equals negative 1/3 times 15 plus b. 15 over 3 is 5 over 1. 0 equals negative 5 plus b. Add 5 to both sides, b equals 5. So now we have the slope of the new line and the y-intercept of the new line. Y equals negative 1/3 x plus 5, but writing it as a function, f of x equals negative 1/3 x plus 5. We okay with that?
Yes.
Any other questions from you or from Antonia before we go on? Okay, then we shall go on to the new material. So let's see here. Need to get rid of that. And I'm not sure what screen I was on, but we'll end up on this screen. So now I want to take a look at this drawing. Okay, so here I have the drawing of a function, and we'll call it function f. Okay. And over on the left, I have some incomplete ordered pairs. What I want to do is look at the graph to complete the ordered pairs. Okay, so the first ordered pair has an x value of 3. So if I go over to the graph and I find the x value of 3, the y value is what at that point?
Wouldn't it be 1?
No. 1 would be up here. X is 3. What's the y value right there?
0.
There you go. You see that, Antonia?
Yes, I see it.
Okay. Now, what about if the x value is negative 2? What's the corresponding y value?
3.
Good. What if the X value is 5? What's the corresponding Y value?
2.
2. Okay, so far so good. So given an X, we look on the graph, we find a point on the graph who has an X coordinate of the given amount, and then we just write down what the corresponding Y coordinate is. Now let's go the other way around. Let's say that we know Y is 4. So where on the graph is Y equal to 4? Wouldn't that be here?
Yes.
-3. It's -3, yes?
-3.
Mhm.
But there's another value, isn't there?
Oh, yes, it'd be 6.
I went off the graph there. What would you guesstimate it would be?
7.
Excellent. So we have 2 inputs with the same output. Is that a function?
Yes.
Yes. We can't have one input going to several outputs and have it be a function, but several inputs to the same output. Okay, now give me a minute here. I'm going to switch screens. All right. Now we're going to do the same thing we just did, only using function notation.
Okay.
All right. So for instance, we've got a graph of f and it says f of -2. Let's see, let's get our color black there. F of -2 would be what? Well, that's like completing the ordered pair, -2 comma something. So on the graph, where is there an X value of -2? That would be right here, wouldn't it?
Mm-hmm.
So what's the corresponding Y value?
2.
-4.
-4, right there. Okay. You see
Yeah.
that?
Yes.
Okay. How about F of 0? When X is 0, what's the Y value?
0.
Right. The graph goes through the origin. Okay, are we all right with that so far? Now we're going to go the other direction. The value of X for which F of X equals 4. So we don't know the X value, but the Y value is 4. So where on the graph is the Y value equal to 4? Right there. You see that?
Yes.
So what's the corresponding X value there?
Two.
2. Okay. The value of X for which F of X is -2. Let's see, where is F of X equal to -2? Right there. What's the X value there?
2. 2.
I think it's
It-
1. -1.
-1. Are you seeing this, Antonia?
Yeah, but it's too tiny. Only. Oh, I got it.
Can you make it bigger on your screen?
Yeah. Yeah, I did.
Okay, yeah, sorry
I
about
couldn't
that.
read.
I've got it full screen here. Okay. Next slide, next question, exact same idea. Now we have this graph called S. Okay. We want to find S of -3. So on this graph, find an X value that is -3. That would be right here. What's the corresponding Y value?
2.
Good. Now, where is there an X value of +3? That's right there. What's the corresponding Y value?
4.
4. Excellent. Right over there. Okay. Now, this part of the problem is slightly different. In problem 17, it said the value of X. This says the values of X, for which S of X is 0. So where is Y equal to 0 on this graph? Well, it's right along the X axis. So what X values have a corresponding Y value that's 0?
-1, 1, and 5.
Excellent. Okay. So there's 3 inputs that go to the same output, triplets. All right. What about S of X equals 3? Let's see, that would be right along here. So what values of X have a corresponding Y value that's 3?
2 and 4.
Good, 2 and 4. All right, we okay with that?
Mhm.
Antonia, okay?
Yes.
All right. Same thing again. G of X equals -2. When G of X equals -2, what does the Y value equal? Wait, I said that wrong. I said when G of X equals -2. No. When X is -2, what is the corresponding Y value? My bad. Sorry about that. So when X is -2, let's see, that's right here. What's the corresponding Y value?
2.
Okay. When X is 0, what's the corresponding Y value?
2.
2.
Good, good. We got a train going by?
Yes.
All righty. Now, the value of X for which G of X is 3. So now we're back to a singular value, the value of X. So X equals, let's see, when G of X or Y equals 3, what is X?
-1.
Good. Find the values of X for which G of X equals -1. So X would be
-3 and 1.
good. Good job. All right, we okay with that one?
Yes.
Find the domain and range of F. Now, we've talked about finding the domain of a function. We did that yesterday where we had the function. Now we're going to look at the graph. So the domain is all the X values of all the points that are on the graph. Okay. Now this graph has arrows going, what, here and here.
Mhm.
Lovely looking drawing, I know. So it goes on and on forever. So what if we took every ordered pair that was on that line and we looked at the X values, do you see that we would have all real numbers?
Yes.
All right. What about the Y values? Would that also be all real numbers?
Yes.
Because as it's going over, it's going down. As it's going over, it's going up. Okay. So the domain and range of this particular graph is all real numbers. Okay.
Mhm.
How about the domain and range of F now? So again, the graph has arrows going over to the right and over to the left. So the domain would be all real numbers. But what about the range? The range isn't all real numbers. Where does the range start? What's the lowest range value?
3.
Okay, and we're going to include 3. So we're going to use
Bracket.
bracket. How far does that go up? How far does the range go from 3?
All real numbers after 3.
Right, so to infinity.
Yes.
So we close up 3 because it's included, and then we don't close infinity because that's not a specific endpoint. Right, we okay with that one?
Yes.
All right. Find the domain and range of f. So now this thing starts right here, but then it goes over and down to the right. So what's the domain? Is it all real numbers?
It starts at 0 and then goes negative, correct?
Careful.
Or maybe not.
Domain. Domain's the x values.
Oh, yes. That way. Wrong way.
So where's it going?
It's all real numbers after 0.
So to infinity. Or as Buzz Lightyear would say, to infinity and beyond. All right. What about the range? What does the range do? What's the smallest value or the most negative value of the range?
Well, it keeps going.
Okay,
So it's infinity and negative and it stops at 0.
so what did you say?
Wouldn't it be then infinity negative
Okay.
infinity?
Yeah, negative infinity. You wouldn't say
Yeah.
infinity negative. So negative
Yeah, I was like,
infinity,
Yes.
and then it stops at exactly 0. So it looks like that. Okay,
Okay.
now we're going to put everything together. F of 1, find f of 1. So where on this graph is there a point or points that has an x value of 1? And be careful, look at the scales, they're not the same.
Is it 3?
Look at the scale.
Oh, yeah. 5. $15?
Yeah, it's funny, I can hear you counting. Let's see, 5, 10, yes, 15. Because right here, the input is 1, but the output is 15 because the scale on the y-axis, each square is 5 units. Okay. All right. How about f of negative 3? Careful again. That's the y value.
5?
Excellent. Okay. Now, the values of x for which f of x is 0.
Zero?
Okay. Yeah.
I'm like, let's see here. Y.
That's not the only one, though.
Oh.
What points on that graph have a y value of 0? What are the x values of those ordered pairs?
-2.
Okay,
-4.
there we go. So -4, -2, and 0. All three of those, they all have an f of x value of 0, So the X values -4, -2, and 0. Okay,
Okay.
what's the domain? The arrows on the ends of the graph imply they continue on in that same direction forever.
So negative infinity. And 1, 2. I'm not sure if it would go straight up from 2 or if it would go
No, it's
outward.
not going straight up.
Okay.
Let's talk about why it can't go straight up. If it was going straight up, it wouldn't be a function
Oh yeah, sure.
because you'd have one X value with more than one Y value. So how far is it going? The domain, as it's going up, it's also going over, right? Ever so slightly, but it is going over.
So infinity.
Yep. How about the range?
And negative infinity, infinity.
Yep. Good job. Any questions?
I'm over here shaking my head like you can see me. I don't.
What's that? Say that again.
I said I was over here shaking my head like you could see me, and I was like, wait, no, no.
All right. Next. Same kinds of questions. Different graph, but same kinds of questions. All right. So G of 1. When X is 1, what's Y?
2.
Excellent. G of -4. Careful. When X is -4, what's Y?
2.
No.
-4. Let me see.
It's not quite negative. I guess it would be -1. Yes.
No.
Mm-mm.
G of -4. Where is X equal to -4? Right here, isn't it?
Yeah.
Oh, it's -2. That's off on my counting.
So what's the Y value?
Negative.
-5.
5.
Yeah. Right here. Okay. Is it that hard to see the graph?
A little
No,
bit.
it looked like it was touching at -2 to me on my side, but
-2?
yes.
That would be right. Oh, I see what you're saying. Yeah, and that's why I emphasize that. Yeah, I got you. That's just my sloppy drawing. Sorry about that.
It's okay.
Okay, the values of X for which G of X is 4.
-2 and 2.
Good. Okay. What's the domain of G? Keep in mind, these are going down, but they're also going over, because if they weren't, it wouldn't be a function.
Mhm.
So what's the domain?
Negative infinity and infinity.
So all real numbers, okay?
Mhm.
What's the range? Smallest to largest.
Four and the negative infinity to 4.
Negative infinity to 4. What's going to happen at 4? Bracket. Okay?
Okay.
So far, so good?
Mhm.
All right, let's see, 72. I gotta look back and see what the instructions were. Hang on. Determine whether each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. So we're going to use what's called the vertical line test, okay? And what the vertical line test says is this. If this is a function, we can draw vertical lines anywhere we want through the graph, and it should never cut through the graph more than once. Well, it does. So this is not a function. For instance, let's take, let's see here. Let me undo this for a minute. Let's take this point right here and this point right there. Okay. What's the x value for both those points?
4.
4.
What's the y value for the bottom point?
-4.
For the top point? Just approximately.
4.
Yeah, sorry. Again, my graphs aren't perfect. Sorry. So what do we have there? We have the same input going to two different outputs. So as far as a vertical line goes, we drew a vertical line and it cut through the graph more than once. That vertical line represents x equals 4. So when x is 4, it takes on two different y values. So this is not a function. And ordered pairs that show it's not a function would be 4, 4 and 4, -4. There's other sets of ordered pairs. For instance, right here, x is 1, y is 2, x is 1, y is -2. Shows that it's not a function, okay? All right. How about this one? Is this a function? Does it pass what we call the vertical line test? Is there a vertical line I could draw that would cut through the graph more than once?
No.
Yes.
Okay, I'm hearing no and yes. Keep in mind, the open circle means that point is not included.
Oh, okay, then no.
That's a no, right? So let's say, for instance, this point was filled in, then it would not be a
Yes.
function, right?
No.
But as it is a function, okay?
Yeah.
So, yes. Okay. How about this one? Is this a function?
No.
It's a poor drawing of a circle, isn't it? Thank you. Thank you for that. Okay. So what about, oh, for instance, right here. So we've got what? 3, -6 and 3, -2. So no, it's not a function. Fails the vertical line test. There's a couple of points that show that it fails. The same x is going to more than one y, so it's not a function. All righty. Well, that's all I have for you today. So for this evening, section 8.3, graphs of functions. I will be back this afternoon at 1:15 with an office hour should you have need of me. Otherwise, I'll see you tomorrow.